Hi, today we'll see immutability. An immutable object is an object that is not changeable and its state cannot be modified after it is created. We cannot override the values of immutable objects. However, we can assign the variable again. In the initial lectures, we discussed about immutable objects. So let's have a look in that again. The fundamental data types are immutable, so int is immutable. Suppose we have this integer x equal to 12, then x points to that object whose value is 12. Now we assign y equal to x, so a new variable y is created which is pointing towards x. So we have x, y and an object of class int with value 12. X and y both having value 12 are referring to the same object. If we print their IDs, then their IDs will be same. ID function in Python refers to the reference of an object and it is unique for a specific object. Okay, now let x equal to 14. So now x is pointing towards 14 and y is still pointing towards x. Here a new object of class int with value 14 is created. So now the IDs of x and y are of that of 14. Now y equal to 13. So y is pointing towards 13. Again, a new object of class int with value 13 is created. Here the IDs of x and y will be different. X is pointing to 14 and y to 13. Now let y equal to 12. Now y is pointing towards 12 again. Here no new object is created. The object with value 12 is already in the memory, so y will acquire the ID of 12 again. This ID is equal to the previous ID of x and y when they were pointing towards 12. So this is the reusability of the variable, and if y equal to 20, then the reference of y will be removed from 12 and it is now pointing to 20. Here the objects which are already present in the memory will not be modified and a new object of class int with value 20 is created and its ID is assigned to the variable y. Let's see them in the code. Making a new folder, 8 immutable reuse. Now a new file, a.py. Let x equal to 12 and print ID of x. Okay, so here let's assign y is equal to ID of x and then print y. The ID of x and y both are same, so print should give same values for these. Okay, so let's see. Running by control 1. See, both the values are same. The ID of x is basically a reference value for x. In other languages, we have the concept of address. So when we print the address of the objects, they usually vary. But here in Python, ID is just a unique value given to the objects and these are internally used by Python and these IDs are platform dependent. The ID for immutable object is created only once until it is destroyed. So when we print ID of x and y, here these both are same. Okay, so now let's see a new example, b.py. Let x equal to 12 and y equal to x. So here the case is same as we have discussed in the slide. If we print IDs of x and y, they should be same. So print id of x and print id of y. So let's see. Look, we are having the same id. Okay. And in Python, we have a keyword is, which is used to test if two objects refer to the same object. It returns true if the two objects are the same, and it returns false if they are not same, even if they are equal. So here x and y both refer to the same object, so the test should return true. So let's see. Print x is y and running. See, we are getting true, means x and y both refer to the same object. Okay. So here's another example. C.py x equal to 12 and y equal to 12, and print id of x and print id of y and print x is y. So here the two IDs should be same and the is test should return true. Okay, so let's see. Running c.py. See, we are getting the desired output. But remember, all these are valid up to a certain range of integers. Outside that range, the same object is not reused. This is because of integer interning. The standard implementation of CPython preloads a global list of integers in the range -5 to 256. Preload means it uses the object which are cached. Anytime an integer is referenced in this range, Python does not create new one but used the cached version. This is known as integer interning. If we take any integer out of this range, -5 to 256, then we can't see reusability. So we can see this with an example. D.py, let x is equal to -12 and y is equal to -12, and if we print x is y and the IDs of x and y, then they will be different. So print id of x and id of y and running. See, false, and IDs are also different. If we take any number inside that range, then the IDs will be same. Let's see. X is equal to -2 and y is equal to -2. -2 is in the range of -5 to 256. Okay. So running. See, true. And the IDs are same as well. Now let's check with another number. X is equal to 256, let's say, and y is equal to 256. And running. Okay, true. Here Python is using the cached version of integers. Okay. Let's take a number out of this range. Let's say -6. X is equal to -6 and y is equal to -6. And running d.py, false. Okay. So this is integer interning. Okay. This is designed by Python for optimizing speed and memory. You can read more about it in the link provided in the description. Now, if we have more than two variables pointing to the same object, then let's see. New example, e.py. Here let's say we have 4 variables and all these variables have same value: a equal to 12, b equal to 12, c equal to 12 and d equal to 12. And let's print id of all these. Print id of a, id of b, id of c and id of d. And let's print is test. Print a is b, a is c, c is d and d is a. Okay, let's run. See, all the IDs are same and we are getting true for is test. So no matter how many variables are assigned to the same value, they all will point to the same object. This is reusability. Okay, new example f.py. Now we have a kind of different value. Let's see, x equal to 1 and y equal to int true. Remember, this is int constructor and true means 1. Okay, so true is 1 and x is already 1. So here x and y should point to the same object. So let's see, print x is y. This should return us true. Okay, so running f.py, true. Okay, so we have seen a couple of examples for same type, that is integer type. You can practice with different data types also. We'll also see them in the further lectures. So that's it for today. See you in the next lecture. Bye bye.